Today we are looking at solving literal equations, and our learning target is that we will be able to solve literal equations for a given variable. First of all, let's talk about what a literal equation is. Literal equations are just equations that consist primarily of letters, so they have more letters than they do numbers. Formulas are an example of literal equations. Each variable in the equation literally represents an important part of the whole relationship expressed by the equation. And just like when we're solving 1 and 2 or multiple step equations, we use the order of operations in reverse. We will do the same thing when we are solving literal equations. So we will look at addition and subtraction first. So we'll look at our desired variable that we're solving to isolate and see if anything is being added to or subtracted from it. Then we will move on to see if anything is being multiplied or divided by anything. And then we will simplify exponents. And lastly, we will work within parentheses. So for example, we have solve for x when you have hx plus y equals w. So x is the variable that we want to isolate. So we ask ourselves first, again, remember we're following PEMDAS in reverse. So we ask ourselves first, is anything being added to or subtracted from the term that has the x variable in it? So here's our variable term, hx, because there's the x. So is anything being added to or subtracted from it? Yes, there is a plus y. Okay, so we want to do the inverse operation of plus y. We will subtract y. And the golden rule of algebra is whatever we do to one side of the equal sign, we need to do to the other. So this leaves us on the left side with hx. Here, y minus y is 0. Bring down the equals. And then we have w minus y. Okay, and then we move on to, so we don't have any more addition or subtraction, so we move on to multiplication and division. Is our variable x being multiplied or divided by anything? Yes, it is being multiplied by h, so we need to divide by h. And whatever we do to one side of the equation, we do to the other. So h divided by h is 1, leaving us with x. Bring down the equals. X equals w minus y all over h. Okay, or we can also separate these, so each term could have been divided by h. Divide the left-hand side by h, divide the w by h, divide the y by h. So another equally acceptable answer would be y equals w over h minus, because we have a minus sign here, y over h. Okay, solve for the indicated variables. 4a minus 2b equals 10, and we are solving for b. So again, we're doing the order of operations in reverse. Okay, is anything being added to or subtracted from our variable term? So here's our variable term. It's a minus 2b. Okay, and there is this 4a over here. It is a positive 4a, so to cancel that out, we need to subtract 4a. 4a minus 4a is 0, leaving us with negative 2b equals. And then when I look at the right-hand side, we normally would write 10 minus 4a, but in algebra, and we've talked about this once, we always want our constant to be last. Okay, so we don't want to have two possible answers, 10 minus 4a and negative 4a plus 10. So we always want to have our variable terms first, and those are always going to be in alphabetical order. So if I had an a and a b, the a would go first and the b one would go next. But then the constant, 10 is constant, it doesn't change, it doesn't vary, it's not a variable, so that would go last. So we will, instead of writing 10 minus 4a, we will write negative 4a plus 10. And then b is being divided by negative 2. So b is being it's being multiplied by negative 2, so we need to divide by negative 2. So this entire side gets divided. Whatever we do to the left-hand side of the equal sign, we need to do to the right. And I prefer to break this apart, at least when you're in Algebra 1, because sometimes kids will accidentally cross-cancel 1, like a 5 and a -1, but they won't cross-cancel this one. So I like to break that apart into 2 pieces. That helps us to remember that we can cross-cancel here. A -4a divided by a -2 is a positive 2a, and then a positive 10 divided by a -2 is a -5. And then number 2, area equals half times base times height. So you probably recognize this formula is the formula for the area of a triangle, right? So when we have a fraction like 1/2, we actually can cancel that out right at the beginning. So we have times 1/2. The inverse would be dividing by 1/2. And how do we divide by a fraction? We multiply by its reciprocal, so times 2. So I'm going to take the entire right-hand side of the equation and multiply it by 2. And whatever I do to one side, I have to do to the other. I'm going to take the entire left-hand side, which is just an a, and multiply it by 2. So the reason I'm doing that is because I want these 2's to cross cancel. Okay, so that leaves me with 1 times b times h on the right hand side. So that's just bh. And on the left hand side, it leaves me with 2a. So 2a. And then I see that I'm solving for h. H is being multiplied by b. So I divide by b to cancel it out, to isolate the h. Whatever I do to one side, I have to do to the other. So divide by b. B divided by b is 1. Any number divided by itself is 1. So we end up with h is equal to 2a over b. H is equal to 2a over b. Number 3, wxyz equals abc. Solve for y. Okay, so this is actually pretty straightforward. Even though it has a lot of variables, we're just isolating y. There's only one operation. Y is being multiplied by w and x and z. So we're going to divide by w and x and z. Divide by w and x and z. Okay, w divided by w is 1. X divided by x is 1. Z divided by z is 1. So on the left-hand side, that leaves us with y equals, and on the right-hand side, that just leaves us with abc over wxz. Okay, and at the beginning of the year, we talked about following that order of operations in reverse, because eventually we would get to situations where we have more complex problems and we need to rely on that order of operations in reverse, and this is an example of that. Okay, so you might recognize this formula as, okay, the perimeter of a rectangle is equal to 2 lengths plus 2 widths. So you should visualize a rectangle when you see that, and we are being asked to solve for w. Okay, so again, we're going to follow that order of operations in reverse. And we're solving for w. So is anything being added to or subtracted from our variable term? So w is our variable, which means that positive 2w is our variable term. Is anything being added to or subtracted from this term? Yes. There is a 2l and it's a positive 2l. So to cancel that out, we need to subtract 2l from each side. P minus 2l. Okay, bring down the equal sign. On the right-hand side, 2l minus 2l is 0, leaving us with 2w, and we are asked to solve for w. So, oops, that's a 2 there. So we'll divide by 2. Whatever I do to one side, I have to do to the other. 2 divided by 2 is 1, so I have 1w equals, here I have p over 2, minus, and then these 2's will cancel out because 2 divided by 2 is 1, so minus l. So w is equal to p over 2 minus l. If you did this division all in one step, you would have p minus 2l all over 2. So p minus 2l all over 2 equals w. And I prefer this way, but they're both good. Okay, either way is correct. Number 5, 10h minus k equals 80d, and we are being asked to solve for k. So we will ask ourselves, is anything being added to or subtracted from the k term? Yes, there's a 10h, so we will subtract 10h. And 10h minus 10h is 0. This leaves us with negative k equals 80d minus 10h. And I'm going to leave it that way because d comes before h alphabetically. So 80d minus 10h. So we're being asked to solve for k, and we so far have negative k. We don't want to know what negative k equals. We want to know what k equals. So we need to either multiply or divide this by 1. Okay, I prefer to divide because I feel like students are less likely to leave out one of the terms or forget to divide one of them if it's just right in front of them. You know, they're right in between getting to the next row. So a negative k divided by a negative 1 is a positive k equals positive 80d divided by negative 1 is negative 80d, and minus 10h divided by 1 is plus 10h. So k is equal to negative 80d plus 10h. And number 6, this is a really nice example of our grouping symbols. So when we think of PEMDAS, okay, we're accustomed to thinking of that p as parentheses. Okay, so really let's think of it as grouping symbols. Okay, GEMS or GEMDAS. Okay, so all grouping symbols. This division bar, this fraction bar, functions as a grouping symbol because we have to take the entire top, simplify it, and then divide by f. So just kind of think of that. We can't just go in and start adding 9d here. These are kind of locked together. So we can't quite get there yet. Okay, so it's like this step has to be saved for last because remember we're doing the order of operations in reverse. So z, is anything being added to or subtracted from our z term? Well, yes, there is a minus 9d, but we can't get to that yet because remember it's in that grouping symbols area. So we don't have any addition or subtraction anywhere outside of that grouping symbol. So then we move on to multiplication and division. Is our variable term, right here it's kind of locked inside of those parentheses, is it being multiplied or divided by anything? Yes, it is being divided by f. Okay, so we want to multiply by f. So I'm going to use brackets on the left side. I'm going to take that entire left side. It's being divided by f. I'm just going to multiply it by f so I can cancel it out. And algebraically, I'm allowed to do that as long as whatever I do to one side of the equal sign, I also do to the other. So I have to multiply this side by f as well. So these f's will cross cancel, leaving us with a z minus 9d equals, and we wouldn't write kf, that's a k, yes, we would write fk because we want that to be alphabetical. And then I put a slash through the z, not to try to be fancy or European, but so that it doesn't get confused with a 2, okay? And so then, now we've kind of unlocked that grouping symbol. Now, within that grouping symbol, it's a little micro order of operations. So we need to solve using the order of operations in reverse now that the grouping symbol or that big division bar has been cleared up. So we're solving for z. So now we're going to start our order of operations over again. Okay, order of operations in reverse. Is anything being added to or subtracted from our variable term? Yes. There's a minus 9d, so we will add 9d. Whatever I do to one side of the equal sign, I have to do to the other. So I have negative 9d plus 9d. Those will cross cancel, and I bring down my a z equals fk plus 9d okay, and then I'm kind of out of room here and I don't want to squish this all here, so I'm just going to rewrite that line. AZ equals fk plus 9d. Okay, and then the last step to solve for z is being multiplied by a, so we divide by a, and I'm just going to leave that all as one big step since we really don't have anything that could cross cancel. If it were a number, I'd probably be more likely to separate that out. A divided by a is 1, okay, and this leaves us with z equals fk plus 9d all over a. Okay, number 7. B minus 4x equals 24, and we're solving for x. So again, order of operations in reverse. And here's our variable term, the x. Is anything being added to or subtracted from the x term? Yes, there's a b, so we will subtract the b. Whatever I do to one side, I do to the other. B minus b is 0, leaving us with negative 4x equals, instead of writing 24 minus b, remember we want to write the variable term first and then the constant last. That's just a good habit to start right from the beginning. So instead we will write negative b because it's minus b plus 24. So we'll just start getting into that habit now. And then x is being divided by or multiplied by negative 4. So we will divide by negative 4. Negative 4 divided by negative 4 is positive 1. So we have positive x equals a negative divided by a negative is a positive. So we have b over 4. And a positive 24 divided by a negative 4 is minus 6 or negative 6. And then number 8, we have s over p plus w equals z, and we are being asked to solve for s. So here's our s term. Remember the order of operations in reverse. Is anything being added to or subtracted from our variable term? Yes, there's a plus w, so we subtract w. So we have s over p equals negative w plus z. And s is being divided by p, so we want to multiply by p. Okay, and remember, so then whatever I do to one side, I have to do to the entire other side. Okay, and then, so we put the parentheses, so we remember to do, to multiply the entire side by p, not just one of the terms. On the left side, those p's will cancel out, s equals, and then on the right side, we will distribute. So p times negative w is negative pw, and p times z is plus pz. So s is equal to negative pw plus pz. All right. Okay, let's flip the page. Okay, so next we are going to learn how to write y as a function of x. So when we're graphing, which we are going to be doing a lot of graphing in Algebra 1 and Algebra 2, it's preferable to have that y isolated so we can really clearly see what's happening to x. So we like to have y by itself for many different forms of equations. So write each of the following equations so that y is a function of x. And again, another way of saying that is that we are solving for y. So in other words, solve for y. Okay, so when we are being asked to write y as a function of x, that means the same thing as being asked to solve for y. So isolate y. And you do need to be familiar with that phrase. You will be tested on that phrase. Write y as a function of x. That means isolate the y or express y in terms of x. So again, for all of these, we're just going to use the order of operations in reverse. Okay, so we're solving for y. Is anything being added to or subtracted from the y term? Yes, there's a plus or a positive 2x, so we will subtract 2x. Okay, 2x minus 2x is 0, leaving us with y equals, and remember we always want to have the variable term first, followed by any constants. So instead of saying 7 minus 2x, we will say negative 2x plus 7. And we box our answer. 12 equals 9x plus 3y. Again, any addition or subtraction will be taken care of first. Here's our variable term. There's our y, so the variable term is 3y. Is anything being added to or subtracted from our variable term? Yes, there's a positive 9y, so we will subtract 9x, so we will subtract 9x. And so we won't write 12 minus 9x, we'll write the variable term first, so negative 9x plus 12. Bring down the equal sign. 9x minus 9x is 0. Bring down the 3y. Okay, then we're moving on to multiplication and division. Is our variable term y being multiplied or divided by anything? Yes, it's being multiplied by 3, so we divide by 3. Okay, 3 divided by 3 is 1. So we have 1y equals 12 divided by 3 is 4, and that's a positive 12 divided by a positive 3, so it's a positive 4. And a negative 9x divided by a positive 3 is a negative 3x. So we get y is equal to negative 3x plus 4. Okay, now on number 3, we have constants on both sides. So before we start using our order of operations, we want to combine like terms. So we want to get all of our constants on one side. Since I'm solving for y, I may as well start getting the y by itself first. So let's cancel out this 2. It is a positive 2, so we will just subtract it. This leaves us with 6y equals 3x plus 2. And then we will just divide each term by 6. This gives us y equals 1/2 x plus 1/3. Okay, so that is looking at solving literal equations as well as writing y as a function of x.